and then length you complete. This is length 6, you go to length 4, length 2, and you're done, and so on. Okay? So I'm not going to, it will take 15 minutes to derive the synthesis. But there is a synthesis procedure in the book that discuss how to go from a general or formal system, peeling off or synthesize all this block. Every time you go from here to here, you want to reduce length by 2. Right? Go 6, 4, 2, we're done. 8, 6, 4, 2, we're done. Right? What else? You want to reserve a commonality. And that's easy because as long as this block is a formula, then you're done. Right? So the synthesis procedure actually discuss how to find this block such that every time you go peeling off a block, you're going back, reduce by 2. Okay? And the third type of this system is a complete system. Question? Okay. So what I'm trying to do here is I'm trying to give you the applied math derivation for perfect construction. Okay, so you see many ways to do perfect construction. All right. So let's see how do I start. Let's look at the filter line. Okay. Let's go. This is C, D. Apply math, we use C and D. So I want to be consistent with all the formulation that you see in the literature. So C will be the low pass filter, D will be the high pass filter. The reason why they use C is this filter is for coarse approximation. Coarse approximation is low pass. Okay? D is for detail. The detail of the signal appear in a high pass. So that's why I go C and D. So coarse approximation and detail. So X of N, C of N, D of N. Now, apply math. Doesn't know Fourier transform, doesn't know Z transform. So all the derivation here is based on time domain. And it goes 60 times right now. So what we'll do next is I'm going to take a vector C, X. We know the coefficients for C and D. We're going to see what happened to this output. Okay, let's go. This is U0, and this is U1. U0, assuming that we have infinite length, scenario. So you don't have to deal with the border either. Okay? So here's U0 equal to. How do I represent convolution in the time domain? Who remember convolution? U0 of N. Let's say C has length 4. Okay? So it becomes easier to work with, right? Summation C of K, X of N minus K. So you have C of 0, X of N, C of 1, x of n minus 1, and so on. Right? It's a sum of flip and shift it. Okay? So you see that the C0, C1, C2, C3 have x. Okay? X of n minus 1, and so on and so forth. So what do I say? I see that it will be C0, C1, C2, C3. Okay. That, this exactly the same as this, okay? That makes it easier to see. Right? If you have longer line, let's go this way. Okay. So C0 n, C1 n minus 1, minus 2, minus 3, and so on. That's convolution. This is a matrix representation of convolution. Have you seen this before? Maybe, right? Most of the time you see convolution like this in Z domain, but you don't see it as written this way. That's how, apply math. That's how mathematicians write. Okay? Yeah, they don't know convolution. Okay. What is the next sample? How do I write the next sample? Shift to the right hand side, right? It means C0, C1, C2, C3. Because the next one, C0 times this one. Okay, and so on. So you can show that it is basically a token matrix. Okay, it's a bad token matrix vector. Okay? Let's look at U1. I'm going to cascade the two together, right? So the top half is U0, second half is U1. They work on the same vector x, right? And they actually align in time. So exactly the same format we have here, copy down, only change from C to D. So yeah, line by line, we copy exactly the same thing. D3, 2, 1, 3, 2, 1, 3, and so on. Okay? Let's look at V, 0 to V1. How do I represent V0 and V1? What happened? What's the difference between V0 and U0? If U0 have blank, 10. What is V0 have blank? 5, right? So I see that there's a reduction in size. Reduction in size, how do I denote here? Suppose this is the 0 time, right? That's the one I say, okay? If this is U0 of 0, equal to that something, okay? That's the one I say. I say V0 of 0 is U0 of 0. I have C3, C2, C1, C2. That is the 0 time. What is V0 of 1? V0 of 2. So we are picking this row. We skip this row. We pick this row. That's second in the count of ways. Right? We're just picking, one here, and then throw away that, next one, and so on. Right? And that's basically just